Now we're going to cover our CPU. The CPU, or a central processing unit, is the brain of the computer. It is the device that does all computation required to make the computer run. The CPU is made out of transistors, which are small electrical switches that help the CPU make decisions and produce an output.
So some key terms that you'll hear about a CPU are listed here. So registers are a type of short-term memory that the CPU uses. The ALU, or arithmetic logic unit, does all the computation required for the CPU. The control unit decodes the supplied instructions and tells the CPU what to do. The clock is basically the heartbeat of the CPU and makes sure that all the CPU is working at the same speed as every other part in the computer. A cache is the CPU's personal memory. It is very small but very, very fast. And the CPU bus, as mentioned earlier, is the way that all the internal CPU components connect with each other.
Here we have the fetch execute cycle. In the fetch execute cycle, each instruction runs through it. First, it fetches the instructions and puts it into the cache. Here it decodes the information. Then, within the execute cycle, it gets the data, then executes the operation.
So some key characteristics in a CPU, or specs of a CPU. Specs stand as a short term of saying specifications, and it generally means like information about the CPU. So some CPU specs that you'll hear about are clock speed / frequency, and this basically indicates the speed that an instruction executes through the CPU. Cores of a CPU indicate the number of independent CPUs on the chip. Now we have about running from anywhere between 16 to 32 cores. This means we can have anywhere between 16 to 32 individual CPUs on one single chip. On-chip memory, or cache, basically means the size of the CPU's internal memory, this piece right here. An instruction set basically determines the compatibility. An instruction set is like instruction set is a code that operates on the computer. There are two main instruction sets, x86 and AMD. These two are different instruction set, which are basically a different type of language that the computer uses to communicate with the components. The bus speed is the speed that information can travel through the bus, the CPU's personal bus. And then power consumption, or heat, basically means how power efficient is the CPU for processing very heavy instructions. And I just want to point out that for CPUs, some of them have, but it's not stated on this diagram, some of them have a small internal GPU, or graphical processing unit, and that's called integrated memory. So alas, that even though conceptually to think about, this diagram is very, very nice, it's not actually how a CPU is built. A CPU is built using something called Northbridge-Southbridge architecture. Basically, the CPU is split up into two different sections, the North Bridge and the South Bridge. The North Bridge is the high-speed hub. It connects the RAM it connects RAM and PCIe to the CPU and other fast components, most of the times even integrated memory. Southbridge architecture is the lower speed Southbridge is the lower speed hub. It connects slow I/O devices such as SATA and PCIe to the CPU.
Here we have Moore's law. Moore's law basically says that all information or transistors will double every 18 months. But more in depth is that Gordon Moore, the founder of Intel, predicted in 1965 that we would cram more components onto integrated circuits. Moore's law interpretation today is that the transistor count on an integrated circuit will double every 18 months, and this has held true since 1970. We are currently living in an exponential world of technological growth.